Now cylinder rolling on the inclined plane. Now there are many cases like in friction we have discussed earlier, that is we consider a wooden block and it was moving on the inclined plane and the direction of the motion is always opposite to the direction of friction. Now here a cylinder is rolling, so its extreme end will be in the form of a circle. So in the figure a circle will be indicated as compared to the whole cylinder. So cylinder rolling on an inclined plane, obviously at a certain angle without slipping. So now it is not simply moving against the friction, it is slipping without slipping. So let us take, now we will just go through with the portion, that is, let us take a solid cylinder of mass n. So what is small m representing? The mass of a solid cylinder. R is the radius of the rolling. R is the radius rolling down an inclined plane having a slope. The friction prevents slipping. So why the slipping is prevented? Because friction is in the opposite direction of the motion. Now we can see the figure. Weight is acting vertically downward. R is the normal reaction. Weight has two components, that is mg sine theta and mg cos theta. These are the two components of mg. And force of friction is given by mu n. That is the definition of force of friction, because mu is coefficient of friction. Mu is normally F over n. Therefore, F is equal to mu n, and mg sine theta overcomes the friction. So body is slipping down in the direction of mg sine theta and the angle of plane is theta. So mg is resolved into mg cos theta and mg sine theta. Mg cos theta is balanced by n and mg sine theta is mainly related to mu n. N is the normal reaction. Free body diagram of a cylinder rolling on an inclined plane without slipping. That is, force of friction avoids the slipping. The center of mass moves parallel to the inclined plane. The various forces involved are. So now many forces are acting. Number one, weight mg of the cylinder acting vertically down. Then comes the normal reaction, which is perpendicular to the plane on which the body is rolling. And third one is the force of friction, that is F is equal to mu n. N is normal reaction. And normal reaction means line perpendicular to the plane. So F is mu n between the cylinder and the inclined surface tangentially upwards. The weight mg can be resolved into two components, which I have just now explained. One of the component will be mg cos theta and other component will be mg sine theta. So mg cos theta is opposite to n and mg sine theta acting down the inclined plane. As there is no motion in direction perpendicular to the inclined plane, n must be equal to mg cos theta. Now we have to just apply the second law of motion, because in the linear motion we consider the second law, that is force is equal to mass into acceleration, or it is m into, and acceleration will be g sine theta minus f. So we will find, according to the Newton's law of motion, F is equal to ma or m into g sine theta minus f. The linear acceleration, that is acceleration in straight line. So linear acceleration is indicated by a and the angular acceleration by alpha. It is related as a is equal to r alpha. Torque and angular momentum is given by torque is equal to r into f. R is a perpendicular distance and f is the force. So tau is equal to force into perpendicular distance, and L is the angular momentum, that is given as I omega. I can be replaced by mr square and omega can be replaced by v over r. And also we know that the value of tau, that is the torque, is dl over dt, that is derivative of L with respect to time. So r into f we are substituting the values. We are again adopting the principle of substitution and elimination. So RF is calculated as IA over R. Now from the above equations, we have F into R is equal to IA over R, or F is equal to IA over R square. That is, mathematically we have calculated the value of F, that is IA over R square. Now substituting the value of F, substituting F in equation. Now which equation? Obviously, earlier we have written an equation that is MA is equal to mg sine theta minus IA over R square. So what we will do, MA and mg sine theta must be at one side and IA over R square will be at the another side, and we will find that MA plus IA over R square will be mg sine theta, and from this equation we get the value of A, and A will be estimated as mg sine theta over m plus 1 over R square. Mg sine theta is along the plane. Now, moment of inertia of a solid cylinder about its own axis of symmetry is I is equal to half mr square. This is the formula for the moment of inertia of a solid cylinder. A is equal to mg sine theta. As earlier in the formula we have explained, denominator is m plus half mr square over r square, and the whole calculated portion will become mg sine theta divided by 3m over 2. So total principle in all these expressions will be substitution and elimination. Some numbers are eliminated, and for eliminated numbers, some important variables are substituted, and we go to the conclusion that is in the form of mg sine theta over 3m over 2. Now, acceleration A, linear acceleration, is less than acceleration due to gravity. So, acceleration of a solid cylinder down the inclined plane is always less than the acceleration due to gravity. You will remember regarding acceleration due to gravity, it is different at different places depending upon the height, the depth, and the sea level. Putting the value of A in the equation, that is in the equation of force, and the final relation will become, that is, half mr square into 2 over 3r square g sine theta. So we know that I is half mr square, F is 1 by 3 mg sine theta. Since force of friction is less than the weight of the body, so mu is equal to F over N, and we will compute the values. That is, for F, it is mg sine theta, and the other value for N, that is 3 mg cos theta. So sine theta over cos theta will become tan theta, and mg will cancel off. So the net number of the coefficient of friction mu, that will be equal to 1 over 3 tangent of theta, because sine theta over cos theta is tangent of theta. Now, for the rolling without slipping, value of coefficient of friction is given like this. Mu is equal to F over N, or 1 over 3 mg sine theta over mg cos theta. Mg will cancel off, so 1 by 3, and the ratio of sine and cosine will be 10. So the net value of mu is equal to 1 over 3 tan theta. Now we have to go through certain examples. There is a cube. Now when we use the term cube, we are referring to there are 12 edges in the cube, 6 faces, all the faces are square faces. There will be 4 diagonals and 8 corners. That is what the characterization property of a cube. So a cube having mass m, side A, is placed on the horizontal surface as shown in the figure. So one of the faces fixed on the surface, and we are referring to that a horizontal force F is acting perpendicular to one of the surface. The force is at point at a height of 3a over 4. That is 3 times of fourth part of A, and A is the side. Find the minimum force required that the cube turns about when its when its edges is. So that is what we have to make calculation for. The Q will turn about an edge O if the torque at O satisfies the following condition. So what are the important conditions? As earlier we have discussed, F into 3A by 4 must be greater than mg into A by 2, or F must be greater than 2 over 3 mg. That is all we calculate from the equations given on the left side. So F must be greater than 2 over 3 mg. Now, minimum F will be equal to 2 over 3 mg. So, again, the same figure is considered. Mg is the weight downward, m is the mass, A by 2, that is half the length, and force is acting at 3 times A by 4.